Okay, so we saw in the previous video that we had 3 times y double prime plus 3 times y prime plus 60 times y is equal to 2 times the cosine of 2t as our equation of motion. And we saw already that the solutions of the homogeneous equation are linearly independent of the forcing term, and so therefore we can find our forcing term as yp of t, I should say our particular solution, as a cosine of 2t plus b times the sine of 2t. Okay, so the next thing for us to do is go in and find our derivatives and then substitute everything in to find the values of a and b. So our derivatives are very simple for this problem. We're going to have our first derivative, our yp prime of t is just negative 2a sine of 2t plus 2b cosine of 2t. And then our second derivative is going to be a negative 4a cosine of 2t minus 4b sine of 2t. So now we need to take these two derivatives and the original function and substitute all of them into our equation. So we've got a 3 times our y double prime, which is negative 4a cosine 2t minus 4b sine of 2t plus 3 times our first derivative, which was negative 2a sine of 2t plus 2b cosine of 2t, and then plus 60 times our particular solution, which is a cosine of 2t plus b sine of 2t, and that must equal out to 2 cosine of 2t. So we can now multiply and distribute everything in, and it's going to be a little bit of work to get there, but we've got a negative 12a cosine 2t minus a 12b sine of 2t minus a 6a sine of 2t plus a positive 6b cosine of 2t plus a 60a cosine of 2t plus another 60 now b sine of 2t, and that's equal to 2 cosine of 2t. So we'll first go in and collect all the cosines. We've got negative 12a of them here, we've got 6b of them here, and another 60a of them right there, equaling 2 of them. So comparing the cosines, we've got a total of negative 12a plus 60a makes a total of 48a. So we've got 48a. And then if we look at the b's, we've got plus 6b. And again, this is times the cosine of 2t. We can now look at the sines. We've got negative 12b and 60b, so that's once again making a 48, but this time around it's a positive 48b, and then we've got the extra sign, which is minus 6a. So minus 6a, that's times the sine of 2t, and again this still equals out to 2 cosine of 2t. We now equate coefficients, so equating the cosines, we get 48a plus 6 times b is equal to a 2. And then for the sines, we've got a negative 6 times a plus 48 times b is equal to 0, since there's no sine functions on the right-hand side. So what's nice is we can now go ahead and solve for a in terms of b and substitute, and we can also do some division. So in the top equation, we'll divide everything by 2. So that's 24a plus 3b equals 1, and then down here we have 6 times a equaling 48b. Dividing both sides by 6, we get a is equal to 8 times b That can now go up into here. So we've got 24 times 8b plus 3b equals 1. 8 times 24 is kind of on the big side, so let's see here. Get our calculator out for that. That's going to be 192. Plus 3 more makes 195, so that's 195b is equal to 1. So b is 1 over 195. And then a is just 8 times that, so a is just 8 over 195. If we now take these two constants and put them together, with our particular solution, we get our yp of t is equal to 8 over 165 cosine 2t plus our b, which is 1 over 100, and we said 95, so I need to erase that. Sine of 2t. And this function right here is, again, our steady state solution for the system. It's the term that is there for large values of t, whereas the general solution, again, which we did not find, but if you were to find the general solution with C1 and C2, that would be the part that decays exponentially to 0.